One of the key pieces here is after the proof is verified on chain, depending on the result of the proof, or depending on the result of the verification, you can actually trigger additional actions on chain. So that makes what you did off of the L1 interoperable with the L1. So it's basically like as if the computation actually happened on the L1.
Hello, and welcome to yet another episode of
GM.
the Solfate Podcast. I don't know if you can tell, if you're watching this, you'll notice my hair is significantly longer than our last episode. It has been 3 months, 4 months since we last recorded something, Nick.
Yeah, something like that.
But
it's been a while since I've recorded.
But we had a great conversation today with Yiwen. I'm butchering her name. I apologize. But she's at Nitro Labs. They're working on Termina, which is basically
very cool.
a network extension stack. She described it as basically deconstructed rollups. So instead of just having kind of generic rollups that aren't super targeted, you can actually just take the piece, the actual tech that you need for your specific problem and implement that. So things like a ZK prover, she called it a batcher, so basically running SVM transactions and then settling asynchronously, things like that, was really cool. I was actually really stoked to learn about what they're doing.
Yeah, it was a really great conversation with her. Like I sort of mentioned this in the show, like I've never really thought about network extensions past the surface level of a roll up or like an SVM layer 2, but there's so much more deep than that. Like there's all sorts of different things. Like Termina specifically, they have the 3 different types of network extensions. You can go on their platform, you click a couple of buttons and you're done. And like the ZK prover is probably the one we definitely focused on the most because I don't know, I think it's the coolest. It's way over my head of like ZK and like the cryptography of crypto. But it's all very cool and it unlocks a lot of really interesting use cases that can just exist now and exist much easier than ever before.
Yeah, really fun conversation. Trigger warning for non-technical folks. We do get pretty deep in the weeds.
Gets deep.
But we do our best every few minutes to try and provide a layman's explanation of what we're talking about. I think it's worth a listen for everyone.
Totally.
Before we jump in, I am going to just do a shameless plug for Unbox, my dev shop. If you need any work done, let me know. We're sort of a software product design and development firm, and we're here to help with anything that you need, whether it's Web 2 or whether it's Solana based. So just reach out and we'll figure something out. But for now, let's jump into what is a really exciting conversation.
Let's go.
Nothing in this podcast is or should be considered financial advice. Any opinions and thoughts expressed are solely those of the individual. They do not represent the opinions of any entity. Enjoy.
Yiwen, tell us about yourself. Like, we'll start with small introductions, I guess, and then
Yes.
I'm sure we'll talk more about the big stuff, about what you're building and that sort of thing. But we can start small.
Yeah, sounds good. So I have a pretty traditional software background. I studied CS undergrad, and then I worked in Web 2 for a few years. So I'm based in San Francisco, and that's why I moved out here. Previously worked for some bigger Web 2 companies like Lyft, Microsoft, and SpaceX as well, although SpaceX is more hardware. And then for the past couple of years have been building and founding in the crypto space. So my initial gateway to crypto was through Ethereum, actually, and my first couple of projects were on Ethereum or EVM compatible chains. Through these experiences, just found working with EVM and trying to do what I wanted to do a bit frustrating, especially coming from Web 2. You don't have to think too deeply about performance because you're running on centralized servers that can just go full speed, and you don't have to think that hard about security as well, because you're building in a closed, permissioned environment. And so having to now take these 2 factors into consideration while building out the business logic of the consumer app at hand just I found very distracting and took away from time I wanted to spend on the actual business logic. And so that's what kind of pushed me to start exploring other alternative VMs, like first Cosmos, the CosmWasm, and then also Solana, the SVM. And with Solana specifically, we got into the space in 2023. So right after FTX, we were coming in as a lot of other applications were leaving. So it was a very interesting time. But from two perspectives, one from the technology side and actually counterintuitively, one from the community side, we saw Solana being really undervalued at the time for its potential and for its contributions. So on technology, SVM, Nick, I'm sure you know all of this already, and James, you as well. Parallel processing, local fee markets, state compression, all of these features were just ready, available table stakes things that weren't available in Ethereum or other chains. And then community-wise, despite token price being single digits at times, we saw a lot of innovation and activity that was still happening on chain. And so these two factors made us think that Solana was quite undervalued. And fortunately, we didn't have to wait too long before the market turned around and there was renewed interest in Solana again. So the core of our project now is focused on the Solana virtual machine, the SVM, and trying to bring as much stuff on chain as possible. So things, data and compute that people are doing off chain right now because it's too expensive to do on chain, we're trying to tie that in as much as possible and bring it on Solana L1.
So I am curious, right? Because you mentioned, we came on to Solana in 2023. What is your group like? What was the focus back then? You sort of mentioned what your focus is now. I'm just curious the evolution behind the team and what your focus was before coming to Solana and how that's shifted.
Yeah, that's a great question. So actually, initially, we were very, very rollup focused, and I can share some of the rationale for why we changed our or shifted our direction a bit. But initially, we were very focused, and we weren't using rollup technology as a way to scale Solana, but rather as a way to bring SVM to other ecosystems. So I mentioned already that I was interested in Cosmos and CosmWasm. So initially, the first prototype of the project was putting SVM on Cosmos and giving Solana developers other areas to deploy outside of Solana so they can have multi-chain deployments without having to re-architect for CosmWasm or for EVM or for other like Move VM. So that was the initial hypothesis of what we wanted to do, where we were co-opting rollup technology not for scalability, but as a virtual layer or virtual machine on top of the physical blockchain or physical machine.
Got it. And then you mentioned that that's no longer the focus. So what sort of made you change your mind and shift back toward let's do this all within Solana, I guess?
Yeah, that's a great question as well. From a lot of the user teams we were talking to, the teams that wanted to deploy on other chains and have multi-chain deployments, we found their focus to be a bit scattered, and the teams that were very focused on just one thing on Solana and doing it well and like getting it done well, those were the teams that we wanted to work with more, and they wanted to be Solana native first and foremost.
Are you saying that like the teams that you were talking with sort of, you gave the CosmWasm example, they were only interested in deploying on Solana mainnet. They didn't really care much about trying to have their programs and smart contracts or any of their business logic for that matter go to any of these other assorted chains, whether it's an L1 or a rollup or any of the app chains or anything like that. Is that what you're saying?
Yes, yeah, that's correct. So they were just generalizing a bit. There were two sets of teams. one were the teams that were trying to go multi-chain, so they already had a deployment on Solana, and then they wanted to capture users from other chains as well, but they wanted to do that quickly without having to rewrite things from scratch to deploy on those VMs, like EVM, MoveVM, CosmWasm, so on and so forth. And so we were targeting those types of teams by building an SVM environment on top of the underlying actual chain. But I think, as has been like discussed broadly in the ecosystem, if you're trying to do multi-chain, it kind of fragments your focus just inherently, and so
Yeah, totally.
you're not really able to do. You're like jack of all trades but master of none in a sense, and so you can get some traction within each of these ecosystems, but it's not as productive as if you just went all in on Solana or on whatever ecosystem, your favorite one, and just did it 100%.
Yeah, a lot of traction in one place is better than a little bit of traction in a lot of places.
Yes, exactly.
Especially when trying to grow a business.
Yeah, especially for a very early stage. It's good to limit your focus and just go deep on one thing.
So what is I mean, I guess I have a lot of questions about the specific sort of tech and product that you guys are building. Before we jump into that, though, I'd love to just have an understanding of your team's sort of overall mission and what you're trying to achieve. I think you've alluded to some of it already, but I want to maybe just call that out specifically.
Yeah, for sure. So, broadly speaking, we're building a network extension stack, and we use the term network extension, Rollups, L2s. All of these are quite loaded, and they have a lot of different connotations and baggage that people associate with them. But to define network extension here, I would say it encompasses a broad set of scaling architectures. So it includes rollups, but it's not synonymous with rollups. It includes other types of architectures like proofs and batchers, and I can elaborate a bit more on what those jargon and like these terms are a bit more, but it's tying everything to the L1. So you're not creating a separate environment where there's state and liquidity that's fragmented and outside of Solana mainnet. That's network extension, and we are building a network extension stack. So that means we're helping teams scale their applications within Solana. So without creating a separate, like we have served rollup cases for some users in the past because that's what they've asked for, but we want to move beyond rollups. We want to move beyond those traditional types of scaling solutions in a way where it's beneficial and it feeds the value back to Solana. So I mentioned earlier in our conversation that we're trying to bring off-chain compute on the L1, off-chain data on the L1, because people typically think we're trying to do the opposite. We're trying to move things off of L1, move data, compute off of Solana mainnet, but in fact, we're trying to do the opposite and go the opposite direction.
Got it.
I love that.
So you're thinking. I'm just gonna reiterate what I heard, just in case, for my own sake, to make sure I understand.
It's the James special right here.
Yeah, and then also to make sure that the listeners are following along. Your focus, and you're here. I did notice it's like there's Termina and there's Nitro Labs. Is there like which of those do we refer to your team as?
Yeah, our team, the company is Nitro Labs, and then
Nitro
the
Labs
product is Termina.
Is
so
Termina.
Similar to Anza, Agave, or Off-Chain Labs and Arbitrum and
Got it.
An iPhone. Yeah.
Got it. Okay. That makes tons of sense.
Arbitrum's labs company is called Off-Chain Labs.
Yes.
I mean, is it even a blockchain? Come on. Okay, sorry, I digress.
No throwing shade on the podcast, Nick. That's how we get in trouble. I'm just kidding. Say whatever you want. All right. So Termina is the project that is focused on network extensions, and the way that you describe it, I think, is almost like a very literal definition of just extending the network, right? Like extending the capabilities of of the Solana network, whether that's through, rollups or some of these other things that you mentioned that I'm sure we're going to dig into. And your goal is to, but you're saying the goal is unlike traditional like L2s and rollups where it's how can we get more stuff happening off of the layer one and then maybe just roll up state to the layer one. You're saying how can we effectively get more stuff to happen on the L1 directly?
Yes. So we want to, yeah, that's like exactly right. We want to make sure the computation and data that people are currently doing off-chain because it's too expensive to do on-chain. We want to pull that on the L1 as much as possible through different mechanisms like ZK proofs via our zkSVM prover or via asynchronous settlement on the L1, where it may be too expensive to do it synchronously and have those transactions land right when you execute them, but have it be done async, where you're committing or forwarding the net state on the L1.
Got it. We've talked about we've had conversations in the past with people that sort of are similar in the sense that we're breaking up the different types of use cases for blockchain and saying some of those need to be atomic and immediate, whereas others might not, right? So like this asynchronous settlement, right? It's like you probably don't want asynchronous settlement for like my Sol balance because then it doesn't work, right? My account could get overdrawn, if you will, and that's kind of defeats the whole purpose. But there could be other use cases, be it gaming or some other type of state that isn't as sort of real time dependent, where like you could do asynchronous settlement and that's fine, and you're basically saying leveraging the security of the blockchain is better than doing this in a completely different environment and then sort of posting results after the fact. Is that kind of what we're getting at?
Yeah, that's correct.
Okay.
And I would say there's a bit of nuance to it as well, where it's difficult to classify an entire vertical or category as being suitable for synchronous or asynchronous settlement. As an example, in the context of DeFi and DEXs, there's projects like CubeNet and Drift where CubeNet is their meta L2, where they can execute trades off-chain and have the price at execution be locked in and then settle that to the L1 in an async manner. And it doesn't matter from the time of execution to the time of settlement, the price of the asset may have increased dramatically or dropped as well. But because the price is locked in at execution, when you settle on L1, it's the execution price. So there can be some delay or some lag between execution and settlement. But if you're relying heavily on someone else's liquidity pools, like a DEX like Orca or Radium or Jupiter, then you need that transaction to be instant on the L1. Because if you wait to send it, then when you execute, the price can be very different from when you initially wanted to execute.
Yeah.
Yeah.
So I think for listeners who maybe are less technical, the way that I would describe that is it's very common in, let's just say like Web 2 development to there's various ways to access and write data, some of which are quicker than others, right? It's like you might sorry, I'm trying to like put this in non-technical jargon, right? But it's like you might have data that has you know it's going to be written to a lot, and so you'll put like a lock on that data so that nothing can write to that spot in memory at the same time and cause problems. But that sort of reduces performance, if you will. But that's a trade-off that you make depending on what you need as a developer. and you're not making that decision based on like an entire vertical of like this type of data we only do it this way, and this type of data we only do it that way. It's highly dependent on the actual architecture of the specific thing that you're writing. And so similarly, you're saying it's like we can't just say all DeFi has to be synchronous and all some other vertical can be asynchronous. You're saying it's very dependent on the way the context of the broader system that has been built and architected. So you might be doing trading, have a trading platform that leverages dexes, but then you might have a trading platform that is more like a cube type of situation, and they're both doing DeFi and trading, but because their individual architectures are so different, they, one might be able to use this asynchronous settlement where the other maybe shouldn't.
Yeah, that's a great summary. So I would say general rule of thumb or heuristic here is if the application is more self-contained, so if it has its own liquidity pools or its own order book, then you can do the asynchronous settlement because all your dependencies are within your own system. But if you're highly dependent on Jupyter or someone else's liquidity pools that lives on chain, then you need to get your transaction on chain as soon as possible, because you can freeze or write lock your own things, but you can't do that to other people's data or prices.
Yeah.
Is that purely just because of like, for the sort of the way I'm thinking about this is basically because of arbitrage bots, like people that are trying to maintain the consistent pricing across, all the dexes and all the centralized exchanges and everything. They're doing their arbitrage, and because these sort of, call them public facing dexes and things, they don't have that write lock ability. You're sort of just like, if you don't do it, you're just like trusting the ecosystem of like, well, I hope this price doesn't change a whole bunch, but if it does, then like sucks.
Yeah, I think arbitrage and people intentionally farming and botting things cause prices to change, but there can be other factors as well. So let's say Nick, you send a transaction to me, and I'm a DEX that is going to be forwarding it on chain to Jupyter async. So you're buying Sol at 120, and then I save that into my system, but I don't send it on chain until an hour later for whatever reason.
Okay.
Maybe there's like a big news thing and the price spikes a lot. So you're actually buying it at way cheaper than what everyone else would be buying it. Or the opposite, like maybe the price will drop a lot and you're actually at a disadvantage for when I eventually send it on chain.
Gotcha. Makes sense. Okay, I feel like we got away from the network extension a little bit. Let's bring it back in. So like, if I have never really thought too much past sort of like the layer 2 and roll up idea of network extensions, like, in your company description or like bio is deploy network extension in clicks. And my immediate perception of that, like even as someone who like does developer relations, was like, oh, layer 2s, rollups, SVM compatible things. I never quite considered that it could be things past that. Like you are describing, like there's tons and tons of things that can be included in this broad network extension term. The things that come to mind are naturally rollups and layer 2s, sure. But then as we're like talking about them, things like Metaplex's digital asset standard, the DAS API, that's effectively a network extension. There are additional RPC methods. There's some off-chain indexing that goes on. That's a network extension, right? What are some of the other network extensions that Termina supports, sort of, and like the most popular ones that people are most interested in, and what are the use cases that they unlock?
Yeah, for sure. One way to describe a network extension, at least in the way that our system works, is sort of like a deconstructed rollup, and like that's how we arrived a bit at like what our system currently looks like. So in the beginning, we were serving mainly rollup use cases, and it makes sense as a jumping off point because that's what people are familiar with. That's the status quo, especially in Ethereum. But when we started working with more and more a broader set of users, we realized in our conversations, they would just point to one part of the stack. Yeah, in these conversations with users, they would just point to one part of the rollup stack and say, we want this. and we don't really need everything else. And so that was what spurred us to break apart what was a very highly integrated rollup stack into individual modules. And these network extension modules now make up the core components of our platform.
Gotcha. Okay. Very cool.
So one of the most popular modules is our zkSVM prover. We spent 3 to 4 months of last year working on shipping this, and it was built on Succinct's SP1, which is a general purpose VM. And we also collaborated with Anza for this as well. So there were, unfortunately, there were a lot of things that we had to change to Agave to make sure it ran inside SP1. And there were many things like time and randomness, like things that were non-deterministic but had to be deterministic in order to run in a zkVM. But the core thing we had to fix or update was memory mapping, because Agave's eBPF interpreter was designed to run in a 64-bit environment, but all zkVMs right now are 32-bit hosts. And so when you just pick up and put the interpreter inside the zkVM, you're going to be accessing all sorts of invalid memory locations because the bit depths are off. And so we actually had to change Agave's core logic in order to make it compatible with 32-bit systems. And we have upstreamed 2 of 3 changes into the original Agave from our fork. And so those 2 changes are now live, and anyone can use them and benefit from them. And the third
That's cool.
the third change is still going through the review process, but we're hoping to get that checked in soon. And so all of these can be available for anyone in the Solana ecosystem to use. So that's sort of the background on the zkSVM and what we did to ship it. How you can use it is it can prove any arbitrary Solana transaction. So if you're sending a payment from your account to someone else's account, or if you're doing a more complex trade, or if even in like a bridging context, which is one of the teams we're working with, that's how they're leveraging it. You use the zk prover to generate a proof over this computation, and it's a fixed size proof. It's always 260 bytes, and then you send those bytes on chain, and we have an on-chain contract that verifies the validity of the proof. And if the proof turns out to be verified successfully, then it can actually trigger additional actions on chain. So in the context of the bridging example, if the proof shows that you've successfully transferred your funds to the bridging escrow account or on the other chain, then this proof can trigger the opposite or opposing bridge contract to send funds to your desired receiver account. Let me know if
does the other chain in that situation have to somehow sorry, we were talking about proving Solana transactions, and then we mentioned another chain which might not be SVM compatible, right? So I'm curious, like what's actually being proven out there?
Yeah, so in this case, it would have to be a Solana compatible chain, like a Solana rollup. Okay. Or if the origin chain is Solana mainnet, then you can take this proof and prove it on the other chain.
Got it.
Or verify it on the other chain.
Got it. That makes more sense. That is certainly I think a cleaner mechanism than I think a lot of bridges have used in the past. Not to knock on bridges, like it's a challenging problem, right? Communicating across multiple chains is tough. But yes, certainly if you can know for a fact that the corresponding transaction on the other chain has already occurred, then you could just go ahead and take action on the destination chain.
Yeah.
But
and more broadly, you can compute over any arbitrary Solana transaction. So you can do all sorts of complex things that would be too expensive to do on the L1 because you don't want to pay a super high amount of fees to get it done. So you can generate this proof in a centralized setting. You only need one server to generate the proof, and then you rely on the cryptography to be verified on chain. And the verification is always constant in terms of cost because you're always verifying 260 bytes.
So let me. I want to make sure I understand that piece really well. You're basically saying that, you know, if there's a high compute task that normally, if you wanted to compute on the Solana blockchain, it would it's basically got to be run by every validator, which
Yeah.
is expensive.
Mhm.
And you're saying you can actually just run that. I'm going to say off chain, but it is something that's running a validator. It's running the sort of
running the
SVM
SVM,
portion. Yeah,
Yeah.
running the SVM portion, not a
Mhm.
full validator that's participating in the network.
Yeah.
But it can run that compute on one machine rather than, you know, thousands of validators.
Mhm.
And then the resulting hash acts as is something that you can then send to the network, and the validators can just verify that result is correct
Mhm.
rather than each of them individually calculating the result.
Yeah, that's exactly right. So if in the case of sort of trustless computation, like let's say, James, you don't trust me and I tell you I did this thing, this is my result. There's only two ways you can do to verify that for yourself. One, you rerun the same computation and check that my answer matches your answer, or two, I generate a proof and then based with the power of cryptography, you can verify the proof and then be confident that my result is the right result.
Yeah, so that makes a ton of sense. And that actually seems like a hugely powerful tool for anyone has some kind of compute heavy you know, product or task or something that they want to basically run on chain, but don't want to spend the money to have it run thousands of times when it only needs to run once.
Yeah, and I would say one of the key pieces here is after the proof is verified on chain, depending on the result of the proof, or depending on the result of the verification, you can actually trigger additional actions on chain. So that makes what you did off of the L1 interoperable with the L1. So it's basically like as if the computation actually happened on the L1.
Yeah. I wanna this is like for the listeners specifically, and just to check my own knowledge here, I want to call that out as like a great example of what you mentioned, like you called it deconstructed rollups, right? Where it's like these network extensions that you're talking about aren't necessarily a full rollup, because if you were to just run this computation on a rollup, you'd have the same problem that we just, you know, described trying to alleviate. You'd still be running this computation across all the validators on the L2. And we're saying we don't need to do that. We just need to run it once and then prove it out. So instead of saying, hey, we're going to try to solve this with an L2 and then put the result back on the L1, we're saying, no, we can just solve this with like one container that runs SVM and then push the result back to the L1 where it gets validated. I think that's really cool to me, right? Is saying, hey, even the notion of a roll up is a little bit too broad a brush for the problem we're trying to solve. We can get more surgical and targeted.
Yeah, that's a great summary. We are, focused on improving these core components and making them very precise and very targeted for specific cases, rather than forcing everyone to use all these components together in a whole roll-up stack. And it's more of all or nothing. Here you can pick and choose, plug and play with the different modules in a way that makes this the most sense for your application.
Yeah. I really like that. Sorry, Nick, it looked like you were going to say something.
Yeah, I was going to ask, so we're talking like pretty abstract in like all of these terms. Can you give us like a really concrete example of maybe something that like one of your customers is already doing with like some sort of like really big compute that they're trying to do, and they want to like send it back on chain using the ZK, back on like say mainnet on Solana using the ZK prover. Like what are a couple of like really concrete examples? Because I'm kind of like, I'm struggling to wrap my head around it. Like it sounds really impactful, but like I'm just a dumb person.
No,
So can
no.
you give like some concrete examples here?
Yeah, that's a great question. So actually, when we first launched the zkSVM improver back in December, so about 3 months ago, most of the inbound that we received and most of the interest that we received were from SVM rollup teams. So these are teams building SVM L2s on Solana or on Ethereum, and they wanted to use this to help secure their rollup, because a lot of these teams, right now it's more of a trusted or semi-trusted setting where there's not really a robust proof mechanism. So if the sequencer that the team is running is malicious or dishonest, there's no way people can really guard against that at this point. And so they were interested in using the zkSVM improver in that context, which is a bit funny because the reason we isolated it is so we can use it outside of rollups, but that's one of the big, I guess, bucket of use cases. And it makes sense because, again, rollups people are familiar with. It's the status quo. This is one of the most natural areas to apply the zkSVM improver to. I would say the other set of use cases is the bridging use case with the bridging team that I mentioned previously. They want to bridge between Solana and other chains and be able to prove the transaction on Solana went through to those other chains without having to rely on a like proof of authority network, kind of like Wormhole, where you have to trust the guardians in order to trust that the transaction went through on Solana, and then you can deduct the funds and send it to the receiver account on the destination chain. So I would say those two are the current big buckets of use cases that we're serving, but we're definitely interested in supporting other cases as well, other types of like complex computation that is
yeah, I was gonna say, which one are you most excited about seeing someone build? Because like most of our audience are developers. Are developers? I don't know. Most of our audience is developers. So like maybe one of them will build it.
Yeah, I think there's like many different use cases that I'm excited about. One of the things I've been thinking about more recently is like trading and DeFi. And the other benefit, which we haven't really touched on, of ZK is that it's also privacy preserving. It adding a bit more nuance. It depends specifically on the type of proof that you're generating, but for the type that we are creating for folks, which is Groth 16, it doesn't leak any information, so it is privacy preserving in that sense. And there's a lot of different DEX teams and DEX aggregator teams are exploring being able to add some sort of permissioned or privacy aspect to their system so that people are less likely to get farmed or botted. And there's like dark pool-esque environments that people have come up with. And so I think a zkSVM and generating a proof over those transactions and then sending those transactions on chain is a nice way to do that without creating like a pool, like a simpler, easier way to get the same result without having to create a pool.
That's interesting.
Okay,
That's
cool.
Interesting. I find that I have some questions that aren't technical. Nick mentioned, a lot of our listeners are developers. I think there are a lot of people who want to work on really challenging technical problems like the ones that you're describing, but maybe don't know what the business model for that is or how to fund it, basically. And so I am curious if you have any thoughts, given your team's experience, on how do you fund these sorts of problems that aren't as direct, or aren't always as direct, where like upfront, these are my customers who will pay me for a product. It's like, well, all I know is that I want to work on this really cool technical problem that I think is valuable, but it's hard for me to pinpoint who it's valuable to, or how to get the payment from them in order to fund it. If that's not relevant to you, that's totally fine. But if you have any thoughts, like, I would be curious to maybe chat about that for a couple.
Yeah. Let me answer what I think you're asking, but please correct me if I'm misunderstanding. I would say to be open-minded with the types of users you're talking to. In the beginning, we had a very fixed persona of our ideal user. And I think that prevented us from engaging in some conversations that would actually be beneficial for us to iterate and build a better product. More recently, we have been open to folks who reach out to us and wanted to use our platform in a way that we didn't originally anticipate or expect. And those conversations have actually given us feedback that have helped us have like a more holistic design and be able to better serve the original use cases, actually taking their feedback into consideration.
So our teams, like when teams come and say, hey, we want to use the ZK prover for, whatever the thing is that they want to use it for, are they paying your team for help with implementation and integration, right? Is it kind of like almost a consulting model within the bounds of what you've already built, or how does that work? That's kind of what I'm getting at, is like trying to explain to developers like how they can monetize these almost more abstract tools that they want to build.
Yeah. In terms of monetizing the zkSVM prover in particular, it's the model is based on usage.
Got it.
Yeah, so the value metric here is proof requests. So how many proofs do you request to the server? And then depending on the size of the proof, then that is the cost that's incurred. But we're very open to even like smaller teams that are more ideating and like they have an idea of what they think the SVM prover could play in their system. And then we are pretty hands-on. We have a lot of back and forth discussions and make sure that the prover is actually serving important role in their system. And it's not ZK just for the sake of ZK because it sounds cool or whatever. It's actually bringing value to what they're building.
Got it. So in order to use the ZK prover, like it's not something that people can run on their own necessarily. It is something that runs through your system.
So people can use it. People can use it and run it in like a self-hosted way, but it's a bit tricky because you need to run it on dedicated hardware with GPUs because proving needs those components. And so they can do that, but it's just much easier for them to send it through us. And so that's what we found.
Got it.
To be. Yeah. Yeah, we would be open to like people wanting to self-host it, but nobody has asked.
Fair enough.
It's often not worth the hassle. But no, that makes a lot of sense. I think there are a lot of people who want to build, these sorts of things and maybe aren't sure what the monetization path is. And I think what I'm getting, from your answers is, if it's actually valuable, then then there will be a path to monetize it in some way, shape, or form. Whether it's like what you're describing, where it's like, hey, this is enormously valuable to people, but it's hard enough to stand up from scratch that people, will basically pay to use your implementation of it. Or if they really wanted to self-host, they would probably pay you to help them stand up their own instance. Right. In which case that's more of like that consulting model that I was mentioning before. But like your answer was, be open to what people need and don't just write it off as like, that's not what I envisioned this being used for. therefore I'm not going to entertain that idea. Instead, like, be willing to hear from all potential customers and hear how they're using things.
Yeah, that's the broad takeaway that I've had from the past couple of months of talking with different user teams. People sometimes can come up with ideas to use your tool or system in a way that you don't expect or anticipate, and being open to that and actually actively listening to them and incorporating their feedback is going to help you build a better product. And I think for a lot of other things, like Solana and totally in the past has said, like, he didn't expect the type of like NFTs and meme coins and whatever to be launched on Solana, and like for Solana to serve those different types of use cases.
What are the, I mean, we already talked about a couple of these, but it's like, if you're looking at the next, let's say 3 years, what are the potential use cases for, Termina that you are most excited about? What are you like, this isn't going to happen right away, but I think 2 years from now, 3 years from now, this could happen, and it just gets you really excited in the morning.
Yeah, so taking a step back and looking at things from a higher level perspective, there has been a pattern of different applications on Solana building network extension like infrastructure already. So when people say Solana doesn't have L2s or whatever, it already has. But these are not your traditional like general purpose optimism Arbitrum L2s. These are very application specific. So we already talked about Cube and CubeNet, which is their Meta L2. That's where trades are executed, prices are locked in, and they settle to Solana and also Ethereum and Bitcoin, I believe, async. There's Drift. They announced Swift a week or two ago, and like that does a lot of the transaction or trade construction and execution off chain with the market makers before then it's actually executed on chain. There's also Get Code, which is like the micropayments service. They have their sequencer that processes payments, and then it forwards them on chain in an async manner as well. And there's like Zeta with their sovereign rollup, their like perp stacks. So there's like examples of all of these teams that are not building network extension infrastructure as a way to serve other users, but rather to solve their own pain points. And those pain points were so strong that they invested time and resources to build out these types of infrastructure. So I think over time, as newer projects reach some level of scale or want to compete with centralized exchanges or like whatever their goal is, they're gonna run into issues trying to do everything they want on chain at the speed and performance that they want. So they'll end up building out micro versions of these types of infrastructure. So our goal here is to make that as easy as possible, not have everyone reinvent the wheel and rebuild the same thing, but have a reusable open source stack that everyone can leverage in a way where it makes the most sense for them.
Awesome. That sounds really, really cool. And I'm excited to see it get the broader use over time. I think as we're sort of reaching the end of time here, is there anything you want to tell the listeners that you haven't already? Anything you want to shill or project you want to talk about? Just sort of the floor is yours, and then we'll wrap things up.
Yeah, for sure. So we spent a bit of time talking about the zkSVM prover, that particular network extension module, and then the two other main modules that our stack provides is the SVM engine, which is a dedicated transaction processing node. It's what I called a batcher earlier in our conversation, and this does the instant execution but async settlement that we've touched on. And then the other main module we have is a data module. And so this enables people to build data rollups on Solana. And if you're unfamiliar with the term data rollup, this is similar to like Grass, their architecture, where they have all of their data off chain on their L2 ledger, but they're posting commitments or cryptographic hashes of this data on chain. So the data module in a regular rollup, it serves as the data availability layer, but for these deconstructed cases, specifically Deepin projects, they work as a way for the Deepin network's nodes to post data and be more closely tied to Solana.
Got it. So 3 main modules that you guys have, available right now that people can use. The ZK prover, your batcher, I don't remember what you called it,
SVM engine, yeah.
SVM engine, and then the data tool. What was that one called?
Data module.
Data module. Cool.
Yep.
So listeners, get in touch if any of those sound interesting. And we might need to do another episode to talk about those other 2, because we talked a lot about sort of like why network extensions, and then we really only covered the ZK prover. Might be interesting to chat more another time about the other 2. But thank you so much for joining us. I learned a ton, and
same.
And I think what you guys are building out sounds really, really cool. I'm excited to see where it goes and what teams and products adopt what you guys are using.
Yeah, thanks for the time and for hosting, James and Nick. Really enjoyed the conversation as well.
Awesome.
All right.
Well,
thank you so much.
Listeners, we'll see y'all next time.
All right. Thanks for joining us for this episode of the Solfate Podcast. I hope you liked it. I know we did. We always have a blast recording with our amazing guests. If you've got a moment, please leave us a review in your podcast app or subscribe on YouTube. And I guess it's time to get some more coffee and get back to work.